Hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Good afternoon. Welcome to today's hearing called The Next Mile, Technology Pathways to Accelerate Sustainability Within the Transportation Sector. I want to thank all of our witnesses for joining us here today. We're obviously discussing a critical topic, how to decarbonize and make more sustainable the cars we use every day, the trucks that handle transportation of our manufacturing and other goods all across the country, airplanes, trains, ships. It's clear that all of this stuff is vital to everyday life, but we have to be smarter about it. In 2017, transportation overtook electricity as the sector of our economy with the highest percentage of greenhouse gas emissions when it got up to 29%. And so finding pathways to reduce these emissions is essential. It's also crucial that we as leaders support jobs and industries at the same time, and I think we can do that. The R&D that we're going to talk about here today will drive the development of these technologies, improve our economy, create new jobs, make us safer, improve national security, all while improving the climate. Our labs, universities, business, and research institutions have all worked on these projects for decades. They've had great success, but a lot of the transportation landscape has not budged. Henry Ford first sold the Model T just over a century ago, and a lot of the cars, trucks, and buses on our roads, the vast majority of them still use a similar internal combustion engine. Larger vehicles, airplanes, trains, and ships become even more complicated. So that's what we're trying to figure out now is how can we finally drive some serious change in this area. Scientists have been working hard at it. We've seen a huge development and growth of clean electric vehicles that can go hundreds of miles on a single charge. We've seen hydrogen vehicles, we've seen hybrid electric, and the demand is continuing to go up and up. In 2018, by our figures, more than 1.7 million plug-in and battery electric vehicles were sold worldwide, which is a 40% increase in just 1 year. 1.7 in 2018 alone. So this is a huge market. The Department of Energy is researching other technologies in this sector as well. Bioenergy Technologies Office is working to develop commercially viable biofuels that are compatible with the infrastructure that we already have. There's a variety of feedstocks being talked about, waste organic materials, crops grown specifically for this purpose. Some of these fuels, known as drop-in fuels, are nearly identical, but they would burn much more cleanly than existing fuels. This means we wouldn't need to make as many changes as we would with a purely electric system, and we're going to go full speed down both tracks. The Fuel Cell Technology Office at DOE is also working to develop hydrogen fuel cells, and I'll just put in a plug. There's a lot of great work being done at a local university for us in Western Pennsylvania, Carnegie Mellon, and the Scott Institute on the future of hydrogen fuel cell technology. All of these things combined will help make our transportation sector more sustainable, although it is incredibly complex. We think that with enough investment on our part, in partnership with private sector and nonprofit university partners, we can solve this riddle. And I think we have to, because someone will solve it. There is enough of demand at this point worldwide that we know some of our closest competitor nations are doing everything they can to dominate the future of electric vehicles and similar technologies, and I want the United States to win that race. So very excited to hear from all of you, and now I will recognize my friend and colleague, the ranking member, Mr. Weber, for an opening statement.
Thank you, Mr. Chairman. I apologize for being a little late. Appreciate you holding today's hearing. I'm looking forward to hearing from our witnesses about innovative transportation technologies and about DOE's research and development activities in these areas. The United States transportation sector is a critical part of the U.S. economy. Annually in the United States, vehicles transport 11 billion with a B tons of freight equal to 35 billion with a B dollars in goods every single day. My District 14 on the Gulf Coast of Texas is the 13th largest exporting district in the country. So the transport of goods for us is huge. Last year, almost 1/3 of the United States energy consumption was used for the transportation of people and goods across the country. Currently, this massive energy is met with petroleum products, which account for 92% of U.S. transportation energy use. It's clear and essential, I might add, that we will rely on this incredible resource long into the future So we need to consider this reality as we seek to reduce emissions and grow other energy sources. As energy demands increase, American researchers are exploring sustainable technologies that will make fossil fuel consumption cleaner and more efficient. They'll introduce new fuel pathways while maintaining U.S. energy security. Industry stakeholders are also prioritizing innovation, commercializing electric vehicles, the chairman talked about, biofuels, and advanced fuel cell technologies. And this afternoon, we'll hear from some of our friends in these successful industries. But although industry is taking advantage of incentives to reduce transportation sector emissions, the federal government still has a significant role to play in conducting fundamental research that will, in fact, drive innovation in these technologies. At the Department of Energy, DOE, sustainable transportation R&D is funded through the Department's Office of Energy Efficiency and Renewable Energy, or EERE, and carried out through its Vehicle, Bioenergy, and Hydrogen and Fuel Cell Technologies offices. It bears repeating that the EERE is by far the Department of Energy's largest applied research program. At almost $2.4 billion in annual funding, EERE is bigger today than all of the department's applied R&D programs combined. Let me repeat that. At $2.4 billion in annual funding, EERE is bigger today than all of the department's applied R&D programs combined. That's huge. Currently, the sustainable transportation portfolio makes up about a third of EERE's budget. Today's hearing also provides an opportunity for us to discuss potential vehicle technology legislation, H.R. 2170, the Vehicle Innovation Act of 2019. This bill would authorize modest growth in funding for DOE's vehicle research activities. It would support a broad range of research efforts to reduce or eliminate vehicle emissions and petroleum usage in the United States. And while it should come as no surprise that I don't agree with everything in this bill, I'm pleased to see that our friends across the aisle are considering a more reasonable approach to funding authorization levels. So, I look forward to the discussion on this bill moving forward, and I want to be clear, I support DOE funding for innovative research in transportation technologies. I'm also supportive of American industry taking the lead and of the kind of basic research that benefits not just transportation, but all energy technologies. As we all know, the majority of the basic research is carried out in our national labs. So I'm pleased that we will hear from not one, but two Department of Energy labs today about how American researchers are leveraging DOE's unique and unparalleled user facilities to drive innovation in transportation technologies. For example, at Oak Ridge National Laboratory, researchers have access to not only the National Transportation Research Center, NTRC, the nation's only transportation-focused user facility, but also the lab's Spallation Neutron Source Center. I can do this. Center for Nanophase Material Science and the Oak Ridge Leadership Computing Facility, which currently houses the world's most powerful supercomputer. When it comes to vehicle technology research, we need to look at the big picture and take the long-term approach. Industry simply cannot conduct the fundamental research needed for the next technology breakthrough. But industry can get these technologies out on the road. By prioritizing basic research capabilities and user facilities that have broad applications, we can still enable the private sector to bring innovative new transportation technologies to the market, while at the same time advancing science and innovation across this American economy. Mr. Chairman, I yield back.
Thank you. Now recognize Chairwoman Johnson for an opening statement.
Thank you very much, Mr. Chairman, and good afternoon. Let me thank you for holding this timely hearing on how we can best accelerate the sustainability of our nation's transportation sector. I also would like to join you in welcoming this distinguished panel of witnesses to the hearing today. This committee recently held a hearing where we discussed the need for a national surface transportation agenda. Today's hearing expands upon our commitment to addressing the environmental impacts of transportation in order to mitigate its impacts on climate change and air pollution. While there are many exciting developments in sustainable transportation, such as electric cars, alternative fuels, and new concepts of mass transit systems, there are also many barriers to these technologies that we as a country must work to overcome. That's why this hearing is so important. The transportation sector's carbon emissions are largely attributable to petroleum-based fuels. A transition to a mix of low-carbon fuels and electricity could reduce these emissions by more than 80% and eliminate petroleum use almost entirely, according to the Department of Energy's Vehicle Technologies Office. While researchers believe that this is technically feasible with technologies that already exist today, further R&D will be critical to reducing their cost and improving their reliability and scalability to meet our economic, environmental, and mobility needs. As I have stated before, my hometown of Dallas is a hub for air travel and freight, two forms of transportation that are particularly challenged to decarbonize. Those sources of emissions are projected to grow in coming years as the demand for travel and goods steadily increases. For example, emissions from aviation currently account for almost 3% of the total global emissions. However, based on current aviation trends, it could grow to be above 4% by 2040, representing 14% of the transportation sector emissions. That number may sound inconsequential, but it is significant when you consider the amount of emissions we must reduce to put us on a path to limit global warming in this century. As I know we'll hear more about from today's panel, several of our national labs and private companies are dedicated to providing solutions to these very challenges. But Congress must also act and allocate low-carbon R&D funding to further drive innovation into this sector. So I look forward to this discussion and to working with my colleagues on both sides of the aisle as we consider ideas to better support the Department of Energy's research and development activities in this crucial area. I thank you and yield back.
If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. First, Ms. Ann Schlenker is the Director of the Center for Transportation Research at Argonne National Lab. Her responsibilities include evaluating the energy and environmental impacts of advanced technology and new transportation fuels. Ms. Schlenker's portfolio includes light and heavy vehicle research with an emphasis on low-carbon solutions. She also helps to lead the DOE student vehicle competitions for advanced powertrain technologies and connected and automated vehicles. Before her position at Argonne, Ms. Schlenker worked for Chrysler for more than 30 years. We also have Mr. James Chen, the Vice President of Public Policy at Rivian Automotive, where he oversees policy issues and is tasked with oversight of regulatory requirements applicable to Rivian's products and facilities. Before his position at Rivian, Mr. Chen worked at the EPA and spent 6 years at Tesla, where he held the position of Vice President of Regulatory Affairs and Deputy General Counsel. Mr. Brooke Coleman is a co-founder and executive director of the Advanced Biofuels Business Council, whose membership includes companies in the advanced biofuels and cellulosic ethanol sectors. The ABBC's mission is to support the development and commercialization of the next generation of biofuels and bio-based products. Dr. Claus is the Director of Sustainable Transportation Program at Oak Ridge National Laboratory. Oak Ridge's sustainable transportation researchers support the development of a range of technologies to improve the energy efficiency of light, medium, and heavy-duty vehicles. Dr. Daniels is a materials scientist by training with over 20 years of experience in the automotive technologies sector. The chair now welcomes Mr. Tonko to the Energy Subcommittee for the day and recognizes him to introduce our last witness, Mr. Cortez. And although it is a welcome for the day, sir, you will always be welcome back, and we would even consider you for full admission
Oh, thank you.
based
Thank
in part
you,
on your performance today.
Music to my ears. Thank you, Mr. Chair. It is my honor to introduce Tim Cortez, the Vice President of Hydrogen Energy Systems at Plug Power, a leader in commercially viable fuel cell systems based in the capital region of New York. With proven hydrogen and fuel cell products, Plug Power replaces lead-acid batteries to power electric industrial vehicles such as the lift truck customers use in their distribution centers. They're headquartered in the 20th Congressional District in Latham, New York, and have facilities in Spokane, Washington, Rochester, New York, Dayton, Ohio, Romeoville, Illinois, and Montreal, Canada. Tim Cortez joined Plug Power as Vice President of Hydrogen Energy Systems in January of 2015. In this role, my friend, Mr. Cortez, is responsible for overseeing the Gen Fuel business, including interactions with customers, partners, and suppliers critical to increasing Plug Power's growing market share within the hydrogen fuel industry. Prior to joining Plug Power, Mr. Cortez served as Chief Technology Officer and Vice President of Engineering at Smiths Power. In these positions, he was responsible for research and development, as well as solutions for global applications. During his tenure at Smiths Power, Mr. Cortez led product line expansion that resulted in a doubling of revenue growth in less than 6 years. Tim has worked in the development of critical power infrastructures in both the data center and telecommunications markets, including positions with AT&T Bell Labs, G&B XI Technologies, and Power Distribution Incorporated. He received his Bachelor of Science in Electrical Engineering from New Mexico State University, and he holds several patents in power system architecture. In 2016, Food Logistics named him the rock star of the supply chain for his work making it possible for smaller truck fleets to adopt hydrogen fuel cell technology. And I'm proud that our capital region's own Plug Power continues to build success as a leader in clean energy in New York and throughout the country, and thank Tim for his leadership and welcome him to the panel today. Thank you, Tim. Thank you, Mr. Chair. I yield back.
And thank you. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in full in the record of the hearing. When you have completed your spoken testimony, we'll start with questions, and each member will have 5 minutes to question the panel. We will start now with Ms. Schlenker.
Chairwoman Johnson, Ranking Member Lucas, Chairman Lamb, Member Weber, and members of the subcommittee. Thank you for this opportunity today. It is my honor to talk to you about how the U.S. Department of Energy national laboratories are helping realize the goal of sustainable transportation. I'm Ann Schlenker, and I'm privileged to lead the Argonne Center for Transportation Research just outside of Chicago. Multiple DOE offices, including the Office of Energy Efficiency and Renewable Energy, fund important research and development at the component, the vehicle, and the transportation system levels. DOE national laboratories create new knowledge, develop, enhance, and analyze automotive and medium-duty and heavy-duty truck technologies, and create new tools. The research spans conventional internal combustion engines, hybrid electric systems, battery electric vehicles, fuel cell electric vehicles, and off-highway applications. At the level of vehicle components, the labs develop and de-risk battery technologies. We test new battery materials, develop scale-up processes for the most promising ones, and ultimately hand that off to industry. Argonne's cell analysis modeling and prototyping camp facility, as an example, has worked with more than 4 dozen industrial partners, from startups to Fortune 500 companies. Our research also encompasses the entire battery lifespan. In February of this year, DOE established a battery recycling center at Argonne with many partners to develop and reclaim and recycle critical materials and components from lithium-based battery technology to recover the economic value. Combustion engines still power the majority of our nation's vehicles. Laboratory research provides deep insights into our combustion processes so we can achieve predictable and reliable engine performance with the lowest possible environmental footprint. Researchers use sophisticated tools like the Advanced Photon Source at Argonne to peer into fuel spray streams to optimize the mixture delivery for cleaner ignition processes. They apply high-performance computing capabilities and artificial intelligent techniques to in-house developed computational fluid dynamic codes in order to better understand combustion variability from cycle to cycle, and then transfer this knowledge to industry. National laboratory researchers investigate the complete supply chain of biofuel production from farm to wheels to assess the energy consumption and environmental impacts of fuels used in ground transportation, aviation, and the marine sector. This life cycle analysis uses Argonne's GREET, Greenhouse Gas Regulated Emissions Model, which enables this fuel comparisons. Fuel cell and hydrogen technology investigations extend from materials to components and vehicles and seek to improve performance, durability, and cost. New approaches to renewable hydrogen production as an industrial fuel choice paired with fuel cell vehicle development have the potential to create market demand. National Laboratories research at the vehicle level includes technology to integrate electric vehicles with the grid and enable faster charging. At the Smart Energy Plaza at Argonne, researchers work to verify the interoperability of chargers and cars. Extreme fast charging and megawatt charging will enable longer distance electric travel, making medium-duty and heavy-duty vehicles more marketable. Finally, national laboratories are experts in the vital study of vehicles within a system. The labs collaborate, and I co-chair the DOE Systems and Modeling for Accelerated Research in Transportation, or the Smart Mobility Consortia, and we focus on connected and automated vehicles, the built environment, alternative fuel infrastructure, freight and goods delivery, and decision science. We use models and field experiments to study the effects of not only advanced vehicles and the infrastructure technologies, but also the impacts of new business models and modes of transportation. The result is a greater understanding from the vehicle to the city level. An example of a key insight from this work is really the consumer appetite for e-commerce as a replacement to shopping trips. One might guess that the frequent trips of an Amazon or FedEx delivery truck to your house results in a net energy penalty. However, system analysis shows the inverse is actually true. Avoiding a personal shopping trip in the family car for the average 8-mile trip as compared to an efficient package delivery system saves overall vehicle miles traveled and energy used. Combining the DOE National Laboratories computational horsepower with our capabilities in artificial intelligence, big data, computation, and predictive analytics gives lab researchers and their partners a scenario-based framework to analyze potential mobility futures. The national laboratories and their facilities are America's powerhouses of science, technology, and engineering. They are principal agents of execution and missions of national importance. I am proud to be a member of the National Laboratory Sisterhood. Thank you for your time, and I welcome your questions.
Thank you. Mr. Chen.
Thank you. Good afternoon, Chairwoman Johnson, Chairman Lamb, Ranking Member Weber, members of the committee and the subcommittee. My name is James Chen, and I'm the Vice President of Public Policy for Rivian Automotive. I wish to thank the committee for the opportunity to testify today on technology pathways to accelerate sustainability in the transportation sector. I've submitted my written testimony and will summarize the points briefly in this verbal testimony. Founded in 2009, Rivian is an independent U.S. company dedicated to keeping the world adventurous through the development, production, and distribution of all-electric pickup trucks and sport utility vehicles, or SUVs. Scheduled to commence production next year from our Midwest manufacturing facility, the R1T pickup truck and the R1S SUV will have a number of compelling features, including a range of up to 400 miles on a single charge, quad-motor all-wheel drive, a 0 to 60 time of 3 seconds, 11,000-pound towing capability, and the ability to ford through 3 feet of water safely due to the sealed components. These are among many of the other features we have built into the vehicle. Backed by strategic investors that include Amazon Inc., Ford Motor Company, and most recently Cox Automotive, we employ over 750 people currently at our various U.S. locations in Plymouth, Michigan, Normal, Illinois, and several locations throughout California. Rivian's products are being developed and released as part of the technology revolution in transportation. In fact, vehicle electrification is the platform that will enable the development, optimization, and introduction of new transportation technologies, such as and including connectivity and autonomy. The benefits of electrification are numerous, and the Chairman, you had mentioned quite a few of these: reducing dependence on foreign oil, promoting use of domestically produced electricity, national security, energy independence, a stronger economy and a cleaner environment. Of these many benefits, 3 of the key benefits include the following that I would like to highlight. First, leadership in technology. Lithium-ion battery technology was invented by an American scientist, now a professor at the University of Texas in Austin. Use of this technology in cars was pioneered and matured by American companies. The U.S. cannot cede leadership and control of this technology to foreign countries who are spending billions, literally billions of dollars, to foster and dominate this transportation technology in their own countries. Second, maintaining this leadership is good for the economy. Using Rivian as an example, we purchased the formerly shuttered Mitsubishi manufacturing plant in Normal, Illinois, back in 2017, less than a year after it shut down. We have already spent tens of millions of dollars in equipment and labor to rehabilitate that facility. When all is said and done, we will have spent over $400 million to rehabilitate this former facility. We will create over 1,000 manufacturing jobs, and we'll be producing, with luck, several 100,000 vehicles out of this facility. Supporting EV technology increases investment in the United States, creating economic opportunity and jobs in America. Finally, electric vehicles are good for the environment. Every electric pickup truck and SUV supplants its internal combustion engine-equipped counterpart, lowering the emission of criteria pollutants and greenhouse gases. Minimizing emissions have very real benefits to public health by lowering the causes of asthma and other respiratory-related illnesses. Introducing electric vehicles reduces greenhouse gases, with 7 of the last 10 years being the warmest on record globally. We must do more to reduce greenhouse gases and mitigate the effects of climate change. While some critics of electric vehicles complain that the technology merely shifts the emissions from the vehicles to power plants at a greater level, this is simply not true. Several studies, including a Bloomberg NET study from just last year, shows that, on average, carbon dioxide from battery electric vehicles are about 40% lower than their internal combustion engine counterparts, even when including the emissions from power plants providing the electricity for these vehicles. And the vehicle emission profile only becomes cleaner over time as power plants improve emission controls, include a greater mix of generation of sources, including renewables. In conclusion, the U.S. is best served by robust investment and support of transportation electrification technologies. Congress has a strong role to play in promoting R&D in this technology and supporting the manufacture and market introduction of this American innovation. Thank you again for this opportunity to testify today. I look forward to your questions.
Thank you. Mr. Coleman.
Thank you. Good afternoon, Chairman Lamb, Ranking Member Weber, members of the subcommittee. My name is Brooke Coleman. I am the Executive Director of the Advanced Biofuels Business Council. The Council represents worldwide leaders developing and commercializing next-generation advanced and cellulosic biofuels, ranging from cellulosic ethanol made from agricultural residues to advanced biofuels made from sustainable energy crops and municipal solid waste. Let me start by thanking the committee and staff for looking at the question of how we are going to make the transportation sector more sustainable. As you know, the transportation sector now emits more carbon than any other in the United States. And yet, take it from the biofuels industry, it is not an easy sector to disrupt. One of the underlying challenges we face on the fuel side is the unfortunate reality that fuel markets are not free markets. They are highly subsidized, vertically integrated, and consolidated. That makes federal agency engagement, from R&D to loan guarantees to vehicle readiness, much more difficult. The corrective policies driving demand for us, like the Renewable Fuel Standard, must move together with front-end technological development and back-end market readiness related to vehicles, pumps, and fuels to be optimized. If one piece falls out, commercial deployment slows, sometimes to a grind. This is where we find ourselves with many advanced biofuel technologies. DOE, together with USDA, was instrumental in pushing cellulosic biofuels forward. We are producing commercial volumes now, but we are also grinding on the scaling side, largely because the demand side part of the equation faltered. And I know this isn't an RFS hearing, but EPA did stop enforcing the RFS for 3 years, starting in 2013, then destroyed 4 billion gallons of policy-driven demand thereafter with the oil refinery waivers you're reading about in the news today. It's just hard to hit milestones when the demand-side policy isn't enforced, and it's hard to expect DOE to absorb 100% of that demand risk. So the question is, where do we go from here? First and foremost, and I'm not just saying this because I'm bookended by them, we need robust support for the national labs. This is the set the record straight, what is actually happening type of work essential for emerging industries, trying to break through information warfare campaigns designed to impede important change. I cannot tell you the number of times I have cited, and my community has cited, vehicle emissions testing led by NREL, carbon modeling led by Argonne, and compatibility analysis led by Oak Ridge to set the record straight against industry-funded misinformation campaigns. Second, programs designed to showcase, perhaps at smaller scale, what can be done in the near term are invaluable. The Co-Optima program is one example. To my knowledge, ethanol is the only cost-reductive technology available today in the transportation sector to reduce GHG emissions. Optimizing its use leverages a global competitive advantage that we have in agriculture and supports rural American economies struggling under the weight of trade wars, more extreme weather, and urbanization. We need to harvest ready-made solutions if we're going to harness the full potential of biomass to displace or compete with petroleum. Demonstrations on the crop side are also valuable. When implemented, the Biomass Research and Development Initiative showcased the degree to which land management practices can reduce carbon emissions while improving bottom lines. New initiatives could be patterned after the Novozymes 1-acre study, which demonstrated the viability of boosting feed, fuel, and energy derived from 1 acre of corn while avoiding 1.1 metric tons of CO2 emissions. Finally, there's the question of where best to engage, and it's a difficult question on the commercial deployment side. For many of our companies, it's all about deployment. There's a big difference between testing a new enzyme at small scale and throwing it into your main fermenter that you rely on every day to pay the bills. There's a difference between turning a bale of Stover into cellulosic ethanol, which we've done many times, and turning a conveyor belt of Stover into cellulosic ethanol. Many of our companies simply don't have the staff, time, and resources to do the planning, engineering, and implementation of plant-scale testing necessary to deploy new technology. The expense of outsourcing stalls the deployment of integrated biorefining technologies that we know to work. That's the sweet spot for expenditure of applied deployment dollars and agency time for us. Of course, many staff, including DOE staff, understand this because they ran programs just like this for several years. An important adjustment going forward would be to balance the desire to focus on ultra-new technologies and overly constrained categories like, quote, non-food, with engagement with ready-made solutions at existing plants that can produce transformative results in the immediate term. There are just too many clear benefits of using commercially available and abundant agricultural feedstocks for renewable chemicals, biodegradable plastic, and new fuels while meeting demand for food and feed. I will also close with a brief appeal. It's not always about budget. We have American-made, deployment-ready, low-carbon bioenergy solutions unnecessarily parked as we speak. DOE has been very supportive of reviewing testing protocols to determine how much corn fiber, cellulosic ethanol conversion we are getting out of our processes. This is a fuel with a 126% benefit over petroleum from a greenhouse gas perspective, a true carbon sink. We don't need technological breakthrough there. We need EPA to cut these technologies loose. And if DOE is qualified, and certainly they are, to engage with us on the testing side, they are more than qualified to engage with EPA, their counterparts in getting these fuels out the door. Thank you very much. We appreciate the opportunity to be here today.
Thank you. Dr. Daniel.
Chairwoman Johnson, Ranking Member Lucas, Chairmember Lamb, Ranking Member Weber, and distinguished members of the subcommittee. Thank you for the opportunity to appear before you today. I'm Claus, Sustainable Transportation Program Director for Oak Ridge National Laboratory. Today I will address the important role that the scientific capabilities and expertise of DOE's national laboratories play in accelerating innovations for an efficient, secure, and sustainable transportation system. Rapidly advancing technology and increased urbanization are changing mobility in fundamental ways. Growing traffic congestion, higher fatalities, and pollution concerns are some of our greatest challenges. Oak Ridge has a rich portfolio of materials, chemistry, computing, and biological sciences. We work closely with DOE's Sustainable Transportation Program to improve energy efficiency and fuel economy for light, medium, and heavy-duty vehicles and mobility systems. Thanks to the nation's investments, Oak Ridge is home to several facilities that help accelerate our scientific breakthroughs. And I want to thank Ranking Member Weber for recognizing some of them. DOE's largest materials R&D program, supporting scientific user facilities focused on understanding, developing, and advancing materials, such as the spallation neutron source and the Center for Nanophase Material Science. The Oak Ridge Leadership Computing Facility, as you mentioned, which hosts the world's most powerful supercomputer summit, with growing capabilities in artificial intelligence and machine learning. The National Transportation Research Center, the nation's only transportation-focused user facility, and the Center for Bioenergy Innovation, one of 4 DOE centers created to lay the scientific groundwork for a bio-based economy. Today, I'll cite 2 examples, one on materials and one on mobility, in which we've leveraged these remarkable assets in collaboration with industry, academia, and other national laboratories to solve problems in the transportation sector. First, we worked with Fiat Chrysler and NEMAC to develop a new alloy for use in more efficient engines that operate at high temperatures. Using supercomputers, we accelerated the development of the new alloy in only 4 years versus what normally takes decades. The new alloy is affordable, easy to cast, and can withstand temperatures nearly 100 degrees Celsius higher than traditional aluminum alloys. Our cast engine has surpassed all expectations. Second, Chattanooga, Tennessee is one of the nation's busiest traffic corridors with highly instrumented roadways. Here, we're working with collaborators to use our artificial intelligence capabilities to discover ways to ease traffic congestion, and cut fuel consumption by at least 20%. We're building a digital twin, a real-time living simulation of all traffic. Moving into the future, we will install Frontier, an exascale computer able to solve calculations up to 50 times faster than today's top machines, exceeding 1 quintillion calculations per second and accommodating much more complex simulations. We believe we can take what we learn in Chattanooga and apply it to solve issues in larger regions and guide solutions on a national scale, and help hubs such as Ranking Member Mrs. Johnson's home airport. Further, we can use artificial intelligence to create simulations of materials and fuels in real-world conditions, analyzing the behavior and interactions of millions of atoms under realistic duty cycles. We're also working on a second target station at the spallation neutron source that will offer up to 1,000 times higher performance with a pulse brightness 25 times greater than currently available. We can probe the structure and function of new complex materials in devices like batteries, ultra-efficient engines, and aircraft turbines at a faster pace. Our nation has wisely invested resources in developing these unparalleled capabilities to support basic science breakthroughs that translate into real-world results. We look forward to continuing our scientific pursuit in support of a safer, more efficient, and sustainable transportation system for the nation's prosperity and security. Thank you for this opportunity, and I welcome your questions on this important topic.
Thank you. And Mr. Cortez.
Good afternoon. Thank you, Chairwoman Johnson, Chairman Lamb, Ranking Member Weber, and the entire subcommittee for inviting me to testify before you today regarding sustainable transportation and the work that is going on in the U.S. Department of Energy's Fuel Cell Technologies Office. I am excited to discuss the role that hydrogen fuel cell technology is playing in sustainable transportation and share my perspective on how Congress and the federal government can enable even greater progress through this pathway. In our core technology platform, Plug Power replaces lead-acid batteries with fuel cells to power electric industrial vehicles such as forklifts that customers use in their distribution centers and warehouses. We have unmatched field experience with over 28,000 fuel cells in the field, many in your congressional districts. We have installed over 80 hydrogen fueling stations in more than 30 states across the United States. Our CEO, Andy Marsh, is the chairman of the Fuel Cell and Hydrogen Energy Association and serves on the Hydrogen and Fuel Cell Technical Advisory Committee, which provides technical and programmatic advice to the Energy Secretary on DOE's hydrogen research, development, and demonstration efforts. Plug Power also participates on the Hydrogen Council, which is a global initiative of 60 leading energy transport and industry companies with a united vision and long-term ambition
for hydrogen to foster the energy transition. The Council estimates that by 2050, hydrogen can help cut global CO2 emissions by as much as 20%, with substantial reductions coming from the transportation sector. In September 2018, the Council adopted a goal to completely decarbonize the production process for hydrogen transportation fuel by 2030. Plug Power looks forward to working with the industry partners and leveraging support for public sector to achieve these goals. The United States has a long history and leadership role in fuel cells. When the Apollo 11 mission put a man on the moon in 1969, the command module's primary source of electricity and drinking water was from fuel cells. Since then, American scientific and industrial ingenuity has ensured that our country became the global leader in hydrogen and fuel cell technologies. This could not have been accomplished without the support and dedication of the United States government, including from this committee. Today's federal support primarily comes from the Fuel Cell Technologies Office housed within the Department of Energy's Office of Energy Efficiency and Renewable Energy. The program leverages the resources of our national laboratories and partnerships with private sector, including Plug Power, to research, develop, and demonstrate innovative, efficient solutions for advancing fuel cell systems and hydrogen energy. The results speak for themselves, with the United States leading the world in deployments of zero-emissions hydrogen fuel cell forklifts and light-duty cars. Additionally, the American hydrogen and fuel cell industry continues to push forward with novel applications for these technologies, such as heavy-duty trucking, maritime vessels, port vehicles, drones, military equipment, and more. Plug Power has been working with the DOE since the company's inception to advance our innovative fuel cell solutions. This started with basic research and development projects, which led to proving the feasibility and utility of powering material handling equipment with hydrogen fuel cells and stationary systems for primary backup power. Once these first-generation systems were ready for deployment, DOE's market transformation activities accelerated cost reductions and promoted customer acceptance for this new alternative energy technology. Thanks to these efforts, Plug Power was able to establish initial relationships with customers, help the company significantly expand, and create an entire new market for hydrogen fuel cell systems. Today, Plug Power continues to work with the DOE to further improve the efficiency of these systems, scale up the production of hydrogen fuel, bring advanced manufacturing processes for our technologies from the laboratory to the factory, and introduce hydrogen fuel cells to new markets and applications. Plug Power is very appreciative of DOE's hydrogen at scale concept, and this program explores the potential for wide-scale hydrogen production and utilization in the United States by leveraging resources from the department, national labs, and an array of diverse domestic industries that can produce and utilize hydrogen fuel. Unfortunately, Plug Power is not currently participating in H2 at scale, but we are hopeful DOE will embrace our priorities since we are the leading user of liquid hydrogen in the United States. Today's urgent focus to mitigate climate change, industrial countries are recognizing the critical role that hydrogen and fuel cells can play in decarbonization policies across sectors. In just the past few years, other countries, including China and other developed nations, have put forth and implemented funds and plans worth billions of dollars to accelerate deployment of these technologies, especially in the transportation sector. To ensure the United States did not fall behind in the global leadership in hydrogen and fuel cell technologies, Congress and the executive branch must ensure policies and incentives are available to American industry to accelerate further deployment. America's approach to sustainable mobility needs to incorporate hydrogen fuel and fuel cell systems into our energy strategy. In our written testimony, you can find detailed recommendations supporting the creation of these policies that will allow for scale of infrastructure necessary to facilitate the widespread adoption of fuel cells. Thank you for the opportunity to participate in this hearing and giving Plug Power the opportunity to talk about sustainability, transportation, fuel cells, and hydrogen technologies.
Thank you. We'll now begin with our questions, and I'll take the first round for 5 minutes. Mr. Chen, I wanted to ask you a little bit about kind of how we got to where your company is today and the role of government and all that. You know, one of the things we're trying to figure out here is exactly how to spend the research dollars that we have in addition to how much we have to spend. And you quoted, I think, the figure of what China has spent just on electric vehicles alone, something like 60 billion. So it shows you the overall amount is really important, I think. But are there connections between some of the federal research and how your company was founded? Was the founder at MIT ever supported by federal research, or can you give us any examples of that?
Yeah, so R.J. Scringe, our founder, as you mentioned, is a PhD mechanical engineer out of MIT. He was a member of the Sloan Automotive Laboratories. So to the extent that there was any government involvement, I am not aware of any direct government involvement, but the investment that is made into DOE to look into these types of technologies certainly is something that raises the entire industry and awareness of electric and battery technology.
And it may be as simple as the fact that one of DOE's big investments was in Tesla, which obviously advanced the whole field of battery technology forward, and I'm sure was in some way a side benefit to you all. On the topic of the lithium-ion battery technology, you rightly raised the fact that China is leading in that area, and I saw some figures from Bloomberg that suggested they could have 3/4 of the world market by 2021, which is not what we want, and we're not feeling optimistic on this side about how we would grow our own market in that. So do you have any ideas or thoughts about what we would do to level that playing field or create an insurance policy for ourselves against China dominating that area?
Well, I think there are a number of programs that could certainly help in that area. I think H.R. 2170 is a good start. As I reviewed the provisions of that bill, it talked not only about research and development into lithium-ion battery technology, but support of creating manufacturing jobs or industries that were creating manufacturing jobs in the United States. You mentioned earlier the Tesla loan from the DOE ATVM program. Certainly that was a huge catalyst for Tesla to make a leap forward. As you noted earlier in my bio, that I was with Tesla at that time. And if folks will remember, in 2008, the credit markets were completely locked up. There was no place to get money due to the Great Recession. So the DOE loan to Tesla really was the financial impetus that allowed that company to move forward with the Model S, which was the very first ground-up all-electric vehicle developed and manufactured in the United States that led to the Model X and later to the Model 3, all while driving down the costs of the battery. So I think there's a number of different areas where government can play in, incentivizing manufacturing, the DOE ATVM loan program, which I understand is still in existence, that can certainly support it, R&D, and then of course incentives such as the IRC 30D tax credit, which I understand is also being considered for expansion. These are all the types of programs that I think can help both drive R&D, manufacturing, and demand and acceptability of these technologies.
Absolutely, thank you. And Mr. Coleman, you kind of closed with a point about how it's not all about budget. I think it is largely about that. It's the creation of the market and the creation of demand that seems to be the biggest factor for a lot of these things at the end of the day. But could you just kind of use my remaining minute to expand on that point a little bit, involving the struggles with the EPA and sort of what we could do outside the budget process to help strengthen that demand or market?
Yes, and I appreciate the question. Thank you. So we're at that point, our industry, where we've been around a little while. We've moved through the R and then the D, and we're probably on the last D on the deployment side. And what happens to us often is we get to that point, and people say it's the valley of death or whatever. It's the market deployment side of things. And because energy markets are regulated, it's like driving. You got to show up with a license plate, you got to have a registration, and you got to have an inspection sticker. And if you don't have one of those things and you try to drive around, you're in trouble. And what happens to us is we often have to navigate the interagency process, and one of those things will hang us up. And so what's happening to us right now on this ultra-low carbon fuel is we have a pathway for corn fiber. And for those of you who don't spend all day on biofuels, corn fiber is just the hard, viscous part of the outside of the corn kernel. That's a cellulose feedstock. It's already at the grain door. And we can produce this stuff commercially. It's hundreds of millions of gallons of ultra-low carbon fuel, and we can't get essentially a registration from EPA to put this out and create a value-added integrated biorefining reality. DOE is remarkably trained. They look at our stuff all the time. And sometimes it's just a matter of DOE engaging, going over there and saying, hey, we're in charge of energy security. We can literally change this equation overnight. Why is this taking so long? And it's a very political process over there, and that's really what I meant.
Thank you. And with that, I yield to the ranking member, Mr. Weber.
Thank you. Dr. Daniel, Ms. Schlenker. Am I saying that right? Schlenker? Okay. In your prepared testimonies, you highlight the importance of sophisticated material science, enabling those tools like Argonne's Advanced Photon Source, APS, and Oak Ridge's Spallation Neutron Source, SNS, as well as the importance of providing updates. So sometimes the budget does count for a little bit, Mr. Coleman. So as you know, this committee has an established history of providing strong bipartisan support for these key user facilities. So how critical, and we'll start with you, Ms. Schlenker, in your opinion, are these resources to enabling innovative R&D in sustainable transportation?
So I think the user facilities are a real gem of the national laboratories to allow access to scientists globally to come into the facilities, and certainly for the U.S. researchers and in industry to have access to the experts for those particular user facilities. In transportation, just as an example for the Advanced Photon Source, we're looking at additive manufacturing as a new technique in transportation for component development.
To make it lighter.
To make it lighter.
Stronger, lighter.
And but it's really, right, putting layer after layer down in deposition and to understand where the voids in the fatigue or the failure modes might really be. So we've had a long-standing program with various OEMs to use that particular facility. We look at fuel spray research from injectors out of an engine to try and reduce the emissions and to have predictability within that. So just an example beyond the high-performance computing that we use all the time. And I want to give Claus some time on this, but those are just two big examples that I think of user facilities in transportation that are used on a daily basis.
Okay. And Claus, she's kind of throwing the ball over to you.
Yeah. Thank you, Ann, for that. Thank you, Ranking Member Weber, for the question. I think this is very, very important. The scientific user facilities at the national labs are really the scientific backbone of our research community and of the DOE system on there. You made it very clear. You said the APS and the SNS, right? There's not two of them, right? These are large tools. They require quite some investment to make them the way they are, and you don't repeat those investments as easily.
And to sustain them, to use that sustainability.
Sustain them is also very expensive, yeah. So what we do is we have trained experts who are world-renowned scientists doing nothing but operating these facilities so they are ready to answer the scientific questions we have and advance the technology. One example, for example, is here when we come with an applied problem where an automotive supplier, this happened in Oak Ridge about 6 years ago, where we had a supplier to Ford come in with it was a body in white supplier. And they had
what kind of supplier?
A body in white supplier. It's a supplier who provides the body shell of the car.
Okay.
And there was a cracking problem at that body in white. And the automotive company said, we cannot accept these any further. We need to shut down manufacturing lines, and we probably need to have some layoffs if we can't resolve that. Facilities like the user facilities are equipped to go all the way down to the atomic level and understand what is the problem. And we were able, in just 3 days' time, to resolve the issue, understand where it's coming from, and the company was able to then find a solution and keep their workforce in business.
And that was for Ford?
This was for supplier to Ford.
For supplier Ford, okay. Well, good, that's a great story, thank you. Short amount of time left. This is actually for all witnesses. Here on the Energy Subcommittee, we'd like to talk about next generation science and technology discoveries. What are some of the recent technology breakthroughs that could be considered next generation discoveries in vehicle technologies? And then we'll jump over to hydrogen fuel research after that. But let's start with you, Mr. Cortez. What are some of the recent technology breakthroughs that you would consider next generation discoveries?
So on the fuel cell side, on a stack level inside the fuel cell, advances are being made with regard to the size and the density and the power performance of the actual stack. So that's allowing us to make the stacks and the fuel cells themselves much smaller, much lighter, and be able to generate more power. So that technology is really going to be crucial in order to improve and go, help with the transportation in terms of getting the additional power for the distances that you need to travel.
Well, thank you. And I'm actually out of time, but let me jump to you real quick, Mr. Coleman. What do you say?
For the record, I am pro budget. I'm very supportive of
For the
it.
record,
Very
okay.
important, yeah.
I gave you a chance to redeem
Yes,
yourself.
thank you. I appreciate
Right.
that.
I didn't want that to fuel any controversy.
I hear you.
Yeah.
On our side, we've been focusing on enzyme efficiency. So from a biorefining perspective, when you improve the enzymes, you're producing fuel and feed. You can squeeze more and more of each product out of every bushel of corn or every whatever.
Okay.
Right, and so that's where we've made a heck of a lot of progress.
Perfect. And I'm out of time, but offline, I want to talk to you about why y'all can't get. You said the EPA to give you was it a permit or designation?
The registration is
Registration. Thank you.
Thank you. Recognize Mr. McNerney for 5 minutes.
I thank the chairman. I thank the witnesses. Excellent subject. Good, interesting information that you're providing. Mr. Chen, in your testimony, you mentioned that Rivian has several battery, powertrain, advanced technology research and development centers in California. What role do you believe the California's regulations have played in fostering innovation in that state? My state.
I think they played a large role in fostering that, not only from the emission standards, but programs such as the ZEV mandate, which really encourage industry to start looking at alternatives like battery electric vehicles. In addition, on a less direct method, by being able to monetize credits from generation and production and introduce into commerce zero-emission vehicles, those types of programs have allowed manufacturers like Tesla and soon Rivian to be able to sell those emission credits to traditional manufacturers to help further fund the efforts by those startup manufacturing companies.
Good. Well, what effect do you think rolling back the clean air rules for California is going to have on incentives for innovation in California and in the United States in general?
Frankly speaking, I think it sends absolutely the wrong signal. I think it's a step backwards towards our movement towards greater fuel efficiency, not just alternatives such as battery electric vehicles, but traditional technologies, basically internal combustion engine equipped vehicles.
I see it the same way. Mr. Schlenker, you noted in your testimony that the application of hydrogen as a fuel choice for U.S. industrial processes could be synergistic with fuel cell development. Could you expand on that a little bit?
We think of some of the very energy-intensive manufacturing processes that we have in the U.S.
Is your microphone on?
Thank you. That could be iron or it could be steel manufacturing as an example, very energy intensive. And to be able to use hydrogen as a fuel source, expanding beyond natural gas or other choices in today's market, we think that has some viability to help create that demand for the hydrogen infrastructure. As an example, we have renewable solar and wind today feeding back into the grid. At times, it's actually in surplus to what the grid can take. It goes into secondary battery storage for the grid. It has another use where it actually could be combined with CO2 and converted into, with electrolysis into hydrogen or other fuel choices. So that's really what we're thinking through, is how to use hydrogen within industrial processes as well to help up that demand, if you will, for the fuel cell vehicle technologies.
Excellent. Mr. Chen, I've read that rare earth materials will be a significant limitation to large-scale adoption of EV technology. Would you comment on that?
Yeah, interestingly enough and ironically, rare earth minerals are probably misnamed because they aren't that rare. Where we really see a problem is supply constraint. Right now, roughly 90% of all rare earth minerals are produced in a single country, China. And this has given them a near monopoly over the supply chain. There are certainly methods or policies that can be put into place to encourage the development of the extraction of these types of resources from places outside of China, including in the United States. To date, I'm aware of only a single operating facility that mines rare earth minerals in the United States. certainly there is room for policies to encourage greater development here domestically.
Thank you. Whoever wants to answer, how does fuel cell technology compare to simple burning of hydrogen for efficiency?
On the actual fuel cell side, in terms of utilizing hydrogen to generate electricity, the fuel cells are about 35% roughly efficient. So we can actually create quite a bit of energy from a kilogram of hydrogen. With respect to others, I guess I would leave to somebody else maybe on the committee that might be able to answer that comparatively speaking.
Burning is going to be less than 35%, I can tell you. Thank you. What about, Mr. Daniel, what about AI, artificial intelligence, for easing traffic and other applications? Has this been proven, or is this still a speculation?
We're working, amongst the national laboratories, we're working on utilizing artificial intelligence to solve these problems. Traffic problems are inherently complex problems in which decisions are made by individual players as a small part of a large system. And in that regard, they're very difficult to control, and they're inherently hard to understand. We're using our supercomputing capabilities across the national lab system to better understand what are the consequences of certain decisions, and how do they play together. We're working on some systems where we can do what we call faster than real-time simulation, where we can do true predictions of a future traffic scenario based on knowledge of a system we have right now. And by doing so, then understand what control mechanisms are needed to really improve traffic and reduce the chances of accidents happening.
Good. Thank you. I yield back, Mr. Chairman.
Recognize Mr. Biggs for 5 minutes.
Thank you, Mr. Chairman. I appreciate all of you panelists for being here today. Mr. Chen, when we consider regulations, do you know, or do you consider that there are regulations that are disincentivizing private industry investment in sustainable transportation R&D?
I'm not aware of any regulation per se. Do you have a particular example of?
I'm asking you to see. I mean, this is the area you're going to be more familiar than I am. So it's pristine, is what you're indicating.
Well, there certainly are programs out there that encourage the adoption of alternative transportation option technologies. So, and as I mentioned to the other congressman, with respect to things like rolling back CAFE and the greenhouse gas regulation, those are exactly the wrong signals. Government has always had a role to lead on innovation in areas of technology improvement, whether it be through emissions or safety.
But what I'm trying to get at is, and if I'm understanding you, I'm trying to find out if there's any kind of government regulations that's actually impeding private sector development. And you said no, I think, is what you told me.
Not exactly. There are certain areas of regulation that do have us locked into existing technologies versus allowing us to foster other developments.
And that's what I would like to know more about. And before we run out of time, I'd ask if that's the case, if you can either get together with me or my staff or shoot me a memo or something like that, whatever, in the areas that you think have locked us in.
Yes, absolutely. I can do that.
I appreciate that. So sustainability within the transportation sector is a reasonable goal, but this issue ought to be, in my opinion, championed by private sector, not the federal government, which is why I'm concerned with the legislation we're exploring today. The Vehicle Innovation Act authorizes appropriations of more than $1.6 billion over 5 years for our research, development, engineering, demonstration, and commercial application of vehicles and related technologies in the United States, which, interestingly enough, is roughly the amount of private equity investment in Rivian company, as reported in Mr. Chen's his written statement. This sounds like an exciting opportunity for the transportation industry, but we have to be cognizant of the federal budget constraints facing our country. And so I just want to cover 2 quick points before I leave here today. the question that I always ask myself is it appropriate for the government to transfer dollars taken by compulsion, which is what we do. When we tax, we are taking dollars by compulsion. There's nobody here that volunteers to do it. Every time we try to have a volunteer taxation program, it fails miserably. So we have to compel it. Should we take that compulsorily gained taxation and provide it to private companies and entrepreneurs to conduct research and development, even if it might provide a goal, an overall good? Now, some economists would argue that such transfers from government to private sector researchers incentivizes inefficiencies, suppresses private equity investment, and creates a path-dependent or increasing return regime that locks research development industry onto a suboptimal path that inhibits movement to the most optimal paths of research and development. Several of you have mentioned today China, and I think we should always respect China has literally spent billions and tens of billions of dollars researching into these areas. But we must also understand and make no mistake, China is a centralized authoritarian nation. They control the money, they control the economy. The leader of that nation, or if you decide that you think there's oligarchs running that nation, those leaders can seize and divest capital from market-driven priorities into government-sponsored priorities. We're competing with that. I recognize we're competing with that. But we have always believed in this nation that a system of freedom of markets will produce innovation, and that will be a more nimble and quick approach and response, and actually be better in the long run. So for me, I look at it and I say, this is an interesting dilemma that we're always in. Do we take this money away from private individuals and transfer to researchers and engineers who are on the cutting edge? There's no doubt you're on the cutting edge of technology. That is what I wonder about. I think about that often, and I think you can surmise where I come out, and with that, my time has expired. Thank you.
The chair will now recognize Dr. Lipinski for 5 minutes of questions.
Thank you. As we play musical chairs here, I want to thank all the witnesses for your testimony today. I've long been interested and done a lot of work on autonomous vehicles. I know that's not what we're here to talk about, but I wanted to start out in talking about autonomous vehicles a little bit, because they do have an impact here on sustainability. First thing, though, in the FAST Act reauthorization, I worked to include a provision to establish a interagency working group under DOT to promote autonomous and connected vehicles. Do you believe that there is a need? Is this something that would be helpful when we're talking about sustainability to have a similar interagency working group, or is there anything in particular you think? The idea is to have more coordination. Is more coordination needed on the issues of sustainability, or would that be a worthwhile just add another layer of bureaucracy? So does anyone have any thoughts on that? Ms. Schlenker?
So I really welcome the question, thank you, because I think we can strengthen the relationship and the collaboration between the Department of Transportation and the Department of Energy. Typically, the Department of Energy will do early TRL, advanced research and development, DOT in this space of smart mobility, smart communities, has been funding demonstration and deployment. DOE is doing a little bit of that, but DOT largely plays in that area. So to have a seamless integration and coordination between the two agencies to further the research, everything from data exchanges, data management, what is the ultimate questions we're trying to answer in a cohesive project across the agencies, I think would further all of us, and it would then allow transfer of that knowledge to other areas for best practice learnings. So I would certainly be all in favor of having some sort of formalized, strengthened relationship between the two agencies.
Anyone else have any thoughts on that? Let's go.
Yes.
Mr.
So
Cortez.
if you look at the Department of Energy's, the Hydrogen at Scale program, you really look at all the elements that are associated with that. The transportation portion is a key element of that entire ecosystem that's developed there. So having better coordination to help drive some of the projects and programs to be able to push that and have the scale that we're looking for from a hydrogen generation standpoint, I think would really be key.
Thank you. Mr. Chen?
Yeah, and I would say that there's certainly a need for coordination, including on the vehicle level. The example that I like to point to is that under DOT, NHTSA regulations, Federal Motor Vehicle Safety Standard 111, you have to actually have rear view mirrors, outside mirrors, and the provisions in the regulation actually use the word mirrors to be able to provide that rearward view. We have shown in the past, both at Tesla and at Rivian, that by getting rid of those mirrors and using streamlined cameras, we can improve the aerodynamic efficiency of that vehicle by as much as 3%. However, that is locked into a DOT regulation. Having coordination between DOE and DOT to look at the benefits of modifying that regulation certainly would be helpful at the vehicle level.
Thank you. Mr. Coleman?
I want to be mindful of your 5 minutes, but coordination is huge for us because it's not uncommon for our companies to be engaged across multi-agencies, and I think there's a lot of efficiency to be gained from that as part of the mission for the group.
All right, and in my last minute here, I want to ask, Ms. Schlenker, have you, at Argonne, has anyone done modeled the impacts of autonomous vehicles on congestion and emission?
So across the national laboratories, we have a big program in smart mobility, and in Argonne co-chairs that I mentioned it. Oak Ridge is a part of it as well, an important player. As we look at automated and connected vehicles, we have sophisticated modeling tools, and we can do transportation modeling work to look at potential futures, traffic flow, looking at these new business models like Uber and Lyft coming in, e-bikes, e-scooters, transit, first mile, last mile challenges that we have. So all of that is included into our sophisticated transportation models. Beyond that, we do physical experiments on connected and automated vehicles and understand what happens with active cruise control or cooperative active cruise control, what the benefits really are in traffic flow and congestion, in speed, as an example. So that is very active research for the Vehicle Technologies Office at large and across the National Lab System.
Thank you. Time expired. I yield back.
Thank you, and the chair now recognizes Dr. Baird for 5 minutes of questioning.
Thank you, Madam Chair, and thank you, witnesses, for being here. Not sure I'll get to ask each one of you a question, but some of my questions relate to almost every one of you, I think. My ag background stimulates this question. I guess, Dr. Daniel, you may be a part of this, and Ms. Schlenker, you may also want to respond. But I think the DOE Office of Science funds about 4 bioenergy research centers, if I'm not mistaken, and they conduct coordinated and geographically diverse research in support of developing a viable, sustainable domestic biofuel and bioproducts industry from dedicated bioenergy crops. Now, in the biofuels research that is conducted at your labs through the Bioenergy Technologies Office, how often do you feel like you collaborate with or leverage the expertise of the Office of Science and these bioenergy research centers, and what do you feel that collaboration is like? So how often do you collaborate, and how do you feel that works?
Thank you for that question. Yeah, the Office of Science investments are very, very important for the success of our sustainable transportation program and our innovations in vehicles and mobility systems. We regularly have interactions with those bioenergy centers. We regularly consult with the scientists in there. We even have scientists who are partially funded through those activities and partially funded through our applied research facilities. That interaction from the Office of Science to the applied research program and handing it off to the private sector, I think, is really what makes us so strong and what is really important for the national lab system.
A similar response relative to the Office of Science in our biofuels research that we do at Argonne In particular, we're looking at feedstocks. We're looking at the opportunity with membrane separations and agricultural land use as an example, and those conversion processes and how you scale that then over into industrial and commercial processes and even into the demonstration phase. So the linkage back to the Office of Science is really important to us, and their expertise in some of these fields is transferred directly over into the applied program.
Thank you. Mr. Coleman, would you care to elaborate, kind of fits into your expertise. Would you care to elaborate on some of the biofuels, bioenergy crops that you're looking into and where that stands?
Well, so our industry, as you know, started with corn because the corn, and by that specifically, it's the inside of the kernel, right? Because that's what is already fermentable. So the corn does the work of making a corn mash that's already fermentable. What's happening now is the industry is self-interested in feedstock diversity. Obviously, they want to be able to not just be tethered to corn prices, but other feedstocks. Where it's gone in phase 2 is waste. So 70% or so of what's in an urban landfill is wood and paper and cardboard. And so you have a tremendous amount of cellulosic material there. And then agricultural residues, corn fiber, corn stover, wheat straw, things like that. So the honest answer is we're working through the waste side because of the low feedstock costs, and we're essentially the demonstration phase on the energy crop side. And a lot of that is really applying efficiencies to existing agricultural commodities to squeeze more product out of those products, efficiencies, and obviously better bottom line. Novozymes, for example, is very interested in alternative crops, some of the miscanthus and the more exciting stuff you hear about on the side.
Thank you. Mr. Chen, you got any? We've got about 48 seconds for two more. Any thoughts on that?
No, Congressman, not on those particular thoughts. Rivian's focused on electric vehicles. We're agnostic as to where the electricity comes from.
Thank you. I didn't think so, but I thought I'd give you a chance. But Mr. Cortez, do you have any thoughts since it's in your DOE?
No, as far as the electricity, we're from a hydrogen standpoint, that's really more the area that we're most interested in terms of the generation and green hydrogen and having the supply where we need it to be to drive the demand.
Thank you. My time's up, and I yield back.
And at this time, the chair would like to recognize Dr. Foster for 5 minutes of questioning.
Thank you, Madam Chair, and thank you to our witnesses. Let's say, as I'm one of the many hats I wear here as the co-chair of the National Laboratories Caucus, and I'd just like to say, we've been having CODELs to, all of the DOE national labs, and the reaction that we get from members when they realize it's the tremendous amount of intellectual horsepower and technical horsepower there is really, I have to say, gratifying. And we're going to be coming soon to Argonne National Laboratory, and we'll, I'm sure, be seeing some of what we're going to be talking about here. And one of the valuable things national labs can do, as well as industry, is to look at the costs and the crossover points for different technologies. For example, if you look at batteries as they descend in cost, they become first viable maybe for automobiles, then later for long haul trucks. Later for, or maybe earlier for things like rail that may be less, less weight sensitive, and eventually airplanes when it all goes well. And so, how much is known about what those crossover points are? At what point are batteries cheap enough that really you'd sort of give up on the internal combustion engine? And we could try my hometown laboratory, Ms. Schlenker.
So maybe I'll try and bail you out from answering on battery costs. So on electric vehicles, if we just reflect back maybe a decade, and for a 250-mile all-electric range electric vehicle, maybe that battery pack, and these again are estimates, was about $45,000. In a decade, we're down to about $17,000 for that battery pack. Where do we think we need to get for this cost parity crossover question, right? We think that range is really about the $7,000 at a pack level, which then informs DOE's goals on their battery research for their targets, as do they put out for the dollar per kilowatt hour at 80. With that said, though, we have to also remember that it's not just simply a one-component focus. You have to pay attention to that entire vehicle, right? So everything from the cost of gasoline as compared to electricity, to insurance and repair and manufacturing costs, all of those other things that play into the total cost of ownership. So do we...
have so Argonne and others have been doing cost estimates for decades on the crossover. And so what we're now able to actually understand is, as you've ramped up electric vehicle production, there have been these cost estimates for how the economies of scale would kick in. And maybe Mr. Chen would be a better person to speak on this. You know, has things gone pretty much as expected? Have there been pleasant or unpleasant surprises for not the battery, but the everything else associated with electric vehicles?
Yeah, actually, there has been a substantial amount of progress in that regard. I think if you look back 10 years ago, 2008 is when Tesla introduced the Roadster, and that was a two-seat sports car that had a battery pack that could run roughly 250 miles on a single charge, and that vehicle cost about $130,000. If you go to where we are today, Rivian will be coming out with its R1T pickup truck, and it starts at a cost of $70,000 for a 105 kilowatt battery pack. So substantially more energy, roughly about the same amount of range as the Roadster back in 2008, but now you've got a vehicle that is substantially larger. So it's not just the battery costs, as you mentioned, Congressman, but it's also the efficiencies in the motor, it's lightweighting the materials, it's looking at the aerodynamics, and it's the energy density of that battery pack. And through the entire course of the last 10 years, there has been substantial progress in all of those areas.
Mm-hmm. So no disappointments in terms of, has anyone taken the time to look backwards at the cost projections that were made a decade ago or two to see if you're, because, you know, there's a danger here looking at the proponents' cost estimates, particularly for scaling and quantity.
Yes, so absolutely, I'd say the biggest disappointment is we're not getting there fast enough. And actually, this hearing is very timely because getting there fast enough is about reducing costs and is about increasing energy density and looking at new technologies.
Yeah, and Mr. Cortez, how do fuel cells fit into this landscape of cost and performance?
Yeah, it's really more about performance. So if you look at, and we think about things as not as an either or, it's an and. There are very good places where, and applications where batteries work really well. When you talk about long haul or range and distance, at some point when you have a battery, in order to increase the distance, you have to add more batteries. When you add more batteries, you're adding more weight, and at some point it becomes difficult. And for us, there's a crossover point from a performance standpoint where fuel cells provides that additional range without that additional burden of the weight. It's more of can you add a larger tank to house the additional hydrogen needed to be able to do that. So there's applications that are really well suited for batteries, and then there's applications that are really well suited for long haul and delivery vans and things like that really, now the payload becomes a critical aspect.
All right, thank you, and I guess my time is up at this point.
And now also from the great state of Illinois, the chair would like to recognize Mr. Casson for 5 minutes of questioning.
Thank you. Technically, it's the greatest state, especially with so many folks from Illinois here. So thank you very much. Thank you all for coming. A couple questions, and the first is a question that just always puzzled me a little bit. My first car was an '84 Honda Civic, super nice car. I was thinking it had an AM/FM radio. I think it had a tape deck. I know it had a rear defroster, and had headlights. I'm not sure what other electric loads were on that car. And, to buy a new car today, you got, GPS, XM satellite radio, heated front and rear seats, maybe a heads-up display on the dashboard, all the new stuff that's coming out, drive-by-wire auto parking, automatic driving. can you just help me understand, Dr. Daniel? I'm curious, number one, you know, I know we've gone from 12-volt batteries to 24-volt batteries and integrated starter alternators. What is happening to the onboard electric loads in a vehicle? And is there any reason to believe that that trend is saturating, or is that just continuing in perpetuity?
Yeah, thank you for that question. I think that's a very timely question when we look at the changes happening in the mobility segment there. I believe that current vehicles, vehicles that have an operator and where a driver is doing most of the work, those auxiliary loads are not quite as critical unless it is in an area like an electric vehicle where every electron counts, right? That's something we really have to look for, and the Department of Energy is looking particularly at research, how can I reduce those loads? But where it really changes the game is when we look at connected and automated vehicles, vehicles that drive themselves potentially, vehicles that need to make decisions based on perception around them. We believe that the auxiliary loads at that point will go through the roof. And that's something where we have no technical solutions right now for, and we need to dramatically reduce the energy consumed by sensors and processing units for those vehicles.
So without asking you to guess on a time, is it reasonable to conclude that at some point just the features that consumers want on a car is going to make electrification substantially inevitable?
I don't know if I can draw that conclusion inherently, but energy efficiency of those components becomes very, very critical. We're seeing very high demands. Some people estimate that in a connected and automated vehicle, we're having like 3 kilowatts of usage for sensors and computing.
Mm-hmm.
Some people put that number as high as 5 or 7 kilowatts.
Okay. Can I at least conclude that getting to some level of plug-in electrification is going to be inevitable, just given the voltage and the amperage that we need on cars?
I believe some electrification will certainly be helping there, but I think there are other reasons why we would want to electrify, not necessarily just the the autonomous side of it. Absolutely.
Of course.
Yes.
So then I get the question, and this is for I guess for Mr. Chen in the first instance. There was this Politico article, I think last week, about the oil companies working very hard behind the scenes to slow the, essentially the deployment of charging infrastructure. What are you seeing, and what are the specific concerns you have that we should be watching for? Because if, in fact, for all the reasons, whether consumer-driven or environmental-driven, the reasons you mentioned, if we know we're going to need that charging infrastructure, what are the barriers that you see that we should be thinking about, even beyond the scope of this committee, to make sure that we get that charging infrastructure out there, given as the oil companies seem to be working hard to prevent it from happening?
Yeah, I would say I did read that article, and to be honest, I was a little bit annoyed by that article because they continued to cite a study. I believe it may have been out of the UK, but that study has been long debunked. It basically was the conclusion that electric vehicles were less efficient than gasoline-powered vehicles. And again, that study has been thoroughly debunked by scientists. I think in answer to your question, I think what the committee should be looking out for is the accuracy of this type of information and the interests of those who would oppose the deployment of electric vehicles and fostering American innovation. What are the goals behind that? Why are they really coming at this angle? As we look towards how we invest American taxpayer dollars into technology, we need to make sure, this committee needs to make sure that those dollars are invested wisely and based on solid information and sound science.
Okay. Well, I'm out of time, but if you have any information specifically about the charging infrastructure of where we should be looking, I'd very much appreciate it.
Absolutely.
Thank you. I yield back.
The chair now recognizes Mr. Tonko for 5 minutes of questioning.
I get to go ahead of the sitting chair. Thank you. Wow, I like it here, So thank you, Madam Chair, and thank you to the subcommittee for holding this hearing, and thank you to our witnesses for the expert testimony that you provide so we can discuss sustainable transportation. I hope the federal government can play a positive role in moving the research and the field forward. As I mentioned earlier, I am so proud to represent the capital region of New York, which is home to many innovative companies, including Plug Power. Plug Power continues to be a leader in the innovation economy. Last month, indeed, I had the opportunity to join them in celebrating the partnership amongst Plug Power, the United States Department of Energy, and FedEx, and Charlotte and Albany Airport to power highly efficient fuel cell-powered ground support equipment through a DOE-funded program. A great feat. So, Tim, congratulations again on that success. In your written testimony, you talk about the DOE market transformation being a key to your success. Can you tell us a little more about how it was successful and how it is leading to additional sustainable transportation technology developments with project partners?
Yes, thank you for the question. Yeah, in 2008, we were awarded the program that allowed us to deliver several hundred fuel cells to customers. And at the time, it was really good timing for the program to come to us because it was at the point where we were just about to introduce that product to the marketplace. And what it really did was it allowed Plug to seed several units with customers to get them to be able to have an understanding of the technology, understand how to use it, understand the value that it brought to them in their organization and their operations, and the ability to actually take advantage of that in the application to make sure they understand all of the performance aspects, any safety concerns that they had, and it really was, a program that allowed them to do trials, if you will, without having to spend significant amount of money for infrastructure and to make a huge commitment on theirs. So it really provided them the avenue to test the technology and prove it within their own operations.
Thank you for that. And what do you think that DOE could do to better strengthen the partnership with the industry? How do we make sure that the U.S. keeps our leadership in hydrogen and fuel cells in the global marketplace?
That's a really good question. I think the DOE does a really good job when it comes to the pure R&D and the funding for the labs and the great work that they're doing. I think some of the areas that could really help with bringing some of these technologies to market and driving the growth with regard to these technologies, both for fuel cells and hydrogen, is ensuring that there's an appropriate amount of funding and programs for some advanced demonstrations. I mean, at some point, you have to take the hard work and all the findings from the lab that was done and determine how do you scale, how do you take it to practice to be able to implement it on a commercial standpoint. So there's a chasm there that exists that would really be good if there was a certain percentage of the DOE dollars, not just for the hard research and the R&D, but also to be able to bridge those gaps.
Thank you. Can you speak to the current supply and demand for hydrogen and how it affects hydrogen fuel cell integration into the commercial market?
Yeah, so supply of hydrogen as it relates to the hydrogen that can be used by fuel cells has been very flat over several years. And the demand that we've seen both from our marketplace as well as light-duty retail vehicles has really started to go up. So the concern that we have is at some point that demand is going to, if things aren't done differently, outstrip some of the supply. And what that does, it creates a scenario for the application in the market to be very concerned about, if I'm going to go and invest in these technologies and I'm going to spend money, what's going to happen if I don't have that supply of hydrogen to be able to continue to use my products? It's like when you and I go buy a car, we don't worry about where the gasoline's going to come from. It's ubiquitous, it's everywhere, and so it's not a care for us. But if you're worried about supply and it's not readily available, it makes you think twice, and then the adoption rate then becomes a difficult factor.
And you state in your testimony that Plug Power participates on the Hydrogen Council, a global hydrogen fuel initiative, which estimates that hydrogen can help cut global CO2 emissions by as much as 20% by 2050. Can you just explain quickly how hydrogen fuel technology adaptation could help achieve this goal?
Yeah, absolutely. So, the byproduct of fuel cells is basically electricity, but there's also a small amount of heat and water. There's no emissions, so it's not like a combustion engine that's putting out emissions. And if you couple that with fuel from hydrogen that could be generated from hydroelectric, wind, solar, Then you've got a clean source of hydrogen going into the units, and you've got generation of electricity powering equipment with no emissions or no byproducts.
Wonderful. Thank you so much, Madam Chair. You've been generous. Thank you. I yield back.
And the chair would now like to recognize herself for 5 minutes of questioning. Mr. Chen, in your testimony, you specifically mentioned rare earth minerals. My colleague, Mr. McNerney, also talked about this in his questioning to you as, an area where battery technology developers in the United States are sort of at the mercy of China, and an example of how foreign dominance is an impediment to the development of electric vehicle technology. In addition to the availability of rare earth minerals, and potentially dovetailing from some of the line of questioning that my colleague Mr. Tonka was asking of Mr. Cortez, what are some of the other long-term impediments you see to electric vehicle adoption in the U.S. market?
Thank you for the question. That's actually a pretty broad question, and I would have a long laundry list of things that could certainly hamper deployment of electric vehicles. I think I have to go back and look at the demand side of this and say that there are still concerns amongst consumers about understanding electric vehicles, the cost, the charging infrastructure, the maintenance requirements. I really think a lot of the impediment is education into the public and the infrastructure.
So why does a company like yours exist?
Well, without trying to sound glib, I mean, it's simply the right thing to do.
Yeah.
A company like Rivian exists because our founder and every member of our company believes in this technology, in the fact that, our mission is to make the world or allow the world to continue to be adventurous. It does not make sense to go out into these pristine areas of the world and do so in a vehicle that is spewing criteria pollutants and creating greenhouse gas emissions. So quite simply, we believe humanity should be out there and enjoying the world and everything it has to offer, but minimizing that footprint as much as possible.
Well, and certainly others agree with you, given the continued investments being made from outside investors in your company. I am so delighted that you're located in Plymouth in the old Burroughs plant, and it is certainly an exciting and vibrant atmosphere that I think is speaking to the demand that exists not only here in the United States, but around the world. And I was wondering, could you shed any light in terms of some of the global competitiveness that you see that we have here in the United States as compared to countries who maybe are making some more prominent and pronounced investments in electric vehicle technology, and where does that leave our consumer base versus what we're seeing internationally?
Sure. So as you mentioned accurately, there is a high demand for our products. We've had several events where we've had folks come out and see the vehicles and generate a lot of excitement and a lot of buzz. That all said, I think the United States has a long way to go still on electric vehicle technology investment. What was mentioned earlier in my testimony and through a line of questionings about other countries, China in particular was mentioned as investing $60 billion a year into electric vehicles, not just to see the market, but for manufacturing and technology. So I certainly think there is a role for the U.S. government to play in investment and certainly looking at how to foster this technology.
Yeah. And with that, I'd love for our labs to chime in here as well and maybe talk a little bit more, in addition to what was so pronounced in your testimony, but how you see yourself interacting with companies like Rivian and the technology demand today and in the future, and what would be required of us to continue to support you in your lab efforts. Mr. Schlenker, if you would like to start, we'd love to hear from you.
So as we think about electric vehicles, and of course the infrastructure has to come along with it, but it's really a dance where you have to have good utilization of that infrastructure. At the same time, the market is there for the consumer pull of the vehicle. And lots of different models available now in electric vehicles. It's wonderful to satisfy that market. But really addressing some of those infrastructure challenges still, everything from faster charging, as I talked about, medium duty, heavy duty, at a megawatt. We are seeing successes with mass transit buses now. When you stop to think about the big 60-passenger bus in there being electrified, Chicago, New York, many other cities as well, that's a real win, where all of a sudden that technology is cost competitive to what previously was a natural gas or other biofuel fueled vehicle.
Yeah, thank you for the question on that. I'm actually really excited to hear about some of the anxieties about the rare earth materials, because I believe we can provide technical solutions on there that maybe those might not be needed as much as they currently are in the future anymore. So as an example, we have developed motor technology in the National Lab system at Oak Ridge National Laboratory with ferrite magnets in them. They don't need rare earth materials in them. Those are potential solutions. In order to solve some of the problems of rare earth supply, some of those issues in the United States is that waste processing is a big problem. So if you mine neodymium, for example, 90% of what comes out of that mine is cerium. We have developed a use for cerium in a new alloy which can be utilized, and therefore with the potential application of that waste product, the cost of providing neodymium has the opportunity to drop. And my last comment on that is we're working with 2 other national laboratories together in an electric drive technologies consortium, where we have the goal by 2025 to reduce the combined size of the power electronics and electric machinery component for an electric vehicle, to reduce that by a factor of 8 compared to what's currently in vehicles in there. All of those technology developments will have a dramatic positive impact.
And with that, I yield back the remainder of my time and would maybe like to pass this over to our, okay, well, we'll say this, that this hearing is absolutely essential, and we thank our partners from the labs who have joined as members of the audience today, and we also thank our industry partners as well as our consortium partners in a topic that is most assuredly going to continue to evolve and capture the imagination of our country and in regions like where I represent. I think the big question around the moonshot for the next 50 years is couched within our ability to get to electric vehicles and get to zero emissions, and how we do that and why we do that continues to drive us forward. So know that the history of today's hearing, the great leadership that we have from Chairman Lamb and the incredible colleagues that I have the privilege of serving on this committee with, will continue to carry the ball forward and develop legislation that will advance the work of our labs and assist the charge to bring electric vehicles and the infrastructure to proliferate them into the marketplace as part of our legislative portfolio. So thank you all so much for being here. The record will remain open for 2 weeks for additional statements from members or for any additional questions that committee members may have of the witnesses. At this time, the witnesses are excused and the hearing is now adjourned. Oh my God, that was great. That was great. Thank you for taking me. Yeah, the Teslas are great.
I drove one too once. It was amazing.
Thomas Massey from Kentucky.